Everyone, let us discuss this example. See, in this example, we have a set U, this set U, and we have to prove that it is an open set. So, see, let us try to understand the example first, then we will go further. See, in this example, we have two functions f and g, which are elements of C close interval 0, 1. That means f and g, both of them are continuous functions and which are defined on close interval 0, 1. And they should satisfy this condition. That means f of t must be less than g of t. In this diagram, you can easily see for each value of t, f of t is less than g of t. After that, u is defined in this way. It is a collection of all continuous functions which are defined on closed interval 0, 1, which will sandwich between f and g. That means function h should sandwich between. So it should be, let me write here. Yes, so suppose this is function h. So it should be a continuous function, and the second thing, if h of t must be greater than f of t and h of t must be less than g of t. Okay. So see, we have to prove that it is open set. Okay, we have to show that it is open set with respect to this norm infinity. So we are familiar with this norm infinity. Let us go further. So tell me how to prove a set is open. We have a very simple technique. We take any arbitrary point, get it, and we try to find a ball around it which is entirely contained in a set U. Then we can declare yes, U is an open set. So the same technique I will follow for this set also, okay, which is a set of functions. So let us take one arbitrary point. Let me mention h belongs to U be any arbitrary element, okay, which is any arbitrary element. Actually, it is a function, okay. So after that, we can say here definitely it is element of h. That means it will satisfy that condition. First of all, it is a continuous function, and the second thing, it will satisfy that inequality. Let me write. So therefore, f of t less than h of t less than g of t for all t belongs to closed interval 0, 1, right? After that, what will I do? We can shift f of t on that side. So therefore, 0 less than h of t minus f of t. I shifted f of t on that side, and if you consider this inequality and if you shift h of t on that side, you will have 0 less than g of t minus h of t, right? For all t belongs to closed interval 0, 1. So this thing we have h of t minus f of t. That means if you subtract f of t from h of t, you will have positive real number, and if you subtract h of t from g of t, you will have positive real number. So with the help of this thing, we can define one thing, okay. So let me write here, h minus f of c1 is equal to infimum of h of t minus f of t, where t belongs to, let me write here in this way, t belongs to closed interval 0, 1. Getting? So what is meaning of that? We are subtracting f of t from h of t, but the point where the function has a minimum value, okay, so the difference should be minimum. In this diagram, you can easily see at this point c1, okay, at this point c1, the difference between h of t and f of t is minimum. So that is nothing but point c1 here, okay. Let me mention for some c1 belongs to closed interval 0, 1. So if you consider functions g and h, in the same way, we can define C2 also. So let me define g minus h of C2, which is equal to infimum of g of t minus h of t, where t belongs to closed interval 0, 1. Getting? So that means it is a point where the difference between h and g is minimum. In this diagram, you can easily see at this point, okay, let me mention this, our C2 will be here, since at this point the difference between value of g and value of h is minimum. Those curves are very close to each other. Getting? At C1, h and f are very close to each other, and at point C2, g and h are very close to each other. So in this way we got. So what will I do? I am defining R now. Since you know that when you take any arbitrary point from a set, our first task is to find a radius, okay, of that ball, such that that ball will entirely lie inside a set U, right? So I am finding that R is nothing but minimum of that is h of c1 minus f of c1 comma g of c2 minus h of c2. See, I will tell you geometrically what we are getting. See, h of c1 minus f of c1, that means this difference we getting, and g of c2 minus h of c2, that means this difference we get. Okay, I will highlight it. So this difference we get and this difference we get. So what will be the minimum value? Okay, out of these two, what will be the minimum value? That is nothing but our radius. So by taking that radius, we will prove that, okay, that ball will lie inside set U. So here I can clearly mention r is greater than 0. I will tell you why. Since h of t minus f of t is greater than 0 for all t, so that's why this one is positive real number. And g of t minus h of t is greater than 0 for all t, so that's why this one is also positive. So if you take minimum of two positive real numbers, obviously you will have a positive real number, so that's why r is greater than 0. So my next step, now my claim is to prove that a ball with center h and radius r will entirely lie inside set U. Okay, so make a screenshot of it. After that we will go further. So now our claim is to prove that open ball with center h radius r is subset of U. So we have very simple technique to prove one set is subset of other. We take one arbitrary point of this set and we will prove that it is in second set. Let us do. Let phi belongs to open ball with center h radius r. So phi belongs to that ball, that means distance of phi from h is less than its radius. So that's why we can write distance. But here distance is defined with the help of norm infinity. So I must write norm phi minus h infinity less than r. After that, what will I do? I will write the definition of norm infinity here. The definition of norm infinity says infimum of mod phi of t minus h of t for t belongs to closed interval 0, 1 is less than r. Okay, so infimum is less than r, that means each of them. Okay, so what can we say? It is less than r. So what can we say here? Sorry, I should write here supremum. Okay, it's a supremum. So supremum is less than r, so that's why each mod is less than r. So therefore we will have mod phi of t minus h of t is less than r for all t belongs to closed interval 0, 1. So you are familiar with one result of mod. Mod a less than b if and only if minus b less than a less than b. That famous result I am going to use. So we will have minus r less than phi of t minus h of t less than r for all t belongs to closed interval 0, 1, right? Can you guess what I am going to do? Yes, obviously I am going to add h of t in all sides. So we will have, if you add h of t minus r minus h of t plus h of t will get cancelled. And if you add h of t here, h of t plus r for all t belongs to closed interval 0, 1. I will call it as 1. Okay, we are going to use this inequality 1 later. Let us come back to the definition of r. So what can we write by definition of r? So let me mention by definition of r. Purposely I have kept, let me write here definition of r. Purposely I kept the definition of r here. So using this definition we can easily write here. See, r is a minimum of both of these values. So that means r is less than or equal to each of them. So therefore r less than or equal to h of c1 minus f of c1, right? And r is less than or equal to h of c2, g of c2, right? G of c2 minus h of c2. But basically h of c1 minus f of c1 was infimum of h of t minus f of t, right? So obviously I can write this is less than or equal to h of t minus f of t for all t belongs to closed interval 0, 1, and same thing for g and h. Since at c2 the difference is minimum, that means actual difference between g and h is more than g of c2 minus h of c2. So the same thing I can write, this is less than or equal to g of t minus h of t for all t belongs to closed interval 0, 1. See, let me remove that one since we have already written and it is not required right now, and we will have some more space to write. Okay, so let us continue it here. See what will we get then. See, I am going to use r and this inequality, a less than b, b less than c. So directly you can write a less than c. So let us focus on this part. I am going to shift see, what will I do? I'm going to shift f of t on this side. So there will be plus f of t. I'm going to shift r on that side. There will be minus r. So we will have, therefore, f of t less than or equal to h of t plus r for all t belongs to closed interval 0, 1. Okay, from this inequality, I will do the same. A less than b, b less than c. So a less than c, right? See, I'm going to shift h of t on this side. So h of t is minus here. If you shift it here, it will be plus. So we'll have r plus h of t is less than or equal to, see, it's less than or equal to, sorry, here, yes, h of t is less than or equal to, what will you get? G of t. G of t, this thing we have. Okay, see, if you shift r on that side, it will have minus sign. So I should mention minus sign here. Yes, for all t belongs to closed interval 0, 1. I will call it as 2 and I will call it as 3. So will you tell me from 1, 2 and 3, what will you get? 1, 2 and 3. Tell me what will you get? So we have f of t is less than or equal to h of t minus r. But h of t minus r less than phi of t. So f of t is less than phi of t, right? And phi of t is less than h of t plus r, and h of t plus r is less than or equal to g of t, so it is less than g of t for all t belongs to closed interval 0, 1. That means phi is bounded between f and g. So therefore the condition is satisfied, right? Condition of u is satisfied, so therefore we can declare, therefore phi is member of u. Actually we had taken phi from this open ball and we proved that it is in u. That means we took one element from first set and we proved that it is in second set. So obviously we can say the first set is subset of second set. Let me mention. Therefore, open ball with center h, radius r, subset of u. Actually we had taken h was actually it was an arbitrary element of u, right? And what we proved finally, we proved that it is possible to find open ball which entirely lies inside set u. So u satisfies the definition of open set and we can declare yes, u is open. Therefore let me mention, therefore u is open set with norm infinity. Okay, so I should mention in which set, in, let me mention, in C close interval 0, 1, that means set of all continuous functions on close interval 0, 1 with norm infinity. So in this way we proved. Make a screenshot of it, then we will stop. Thank you. Bye bye.